Now we shall study a very important topic by name graphs. Here we are studying a body which is already in motion, set into motion and running here, and the observer is standing here and has started recording that this point is the initial velocity at this time 10:10, and by 10:20 the vehicle has reached here and obtained a velocity. Here it is 8 kilometers per hour, it is 15 kilometers per hour. It has accelerated, the vehicle has increased its velocity, and that point the observer has noted, and on the graph we shall see what it is. If a body is starting from rest, then the x and the y axis will be 0 and the graph will start from here. But since I have already told you that the vehicle is moving, already started moving very much earlier than the observer. Now the observer has started his observation at 0.8 kilometers per hour. Therefore, when the velocity is here, and the moment he started observing, when the car reached this position, it has been running from a distance prior, and once it reached this point, the time may be 10:10, and by the time it reached here, it would be 10:25 or something, any time that the observer will be noting. The observer has started observing at time t1, and the delta t is nothing but t2 minus t1 after 15 minutes. As you can see, this is the 15 minutes, and the car has moved with uniform velocity and reached a position B from position A. This is the position A and this is position B. And this area under the graph gives the displacement derivation. Since the car has reached this point, this would be the final velocity, this being initial, and the value can be noted at this point on the graph. This is V, this is point U. This will give the reading of U and this will give the reading of V, and this will give the reading of T, delta T. And now we can derive acceleration from this graph. It is nothing but rate is time, and change of velocity is nothing but V minus U. So here comes the acceleration derivation from the above graph. And for displacement, the area under this line gives the area of this figure under the line gives the displacement derivation. We can simply drop a perpendicular onto this line, and we can see that this is a right angle triangle and here there is a rectangle. Know that area of a right angle triangle is of any triangle is half into base into height, and this being the perpendicular, this would be the height, and naturally this will be the base of the triangle. And if I wish the triangle this way and the 90 here, then this would be the perpendicular and this will be the base, and the area will be half AC into BC, AC being T and BC being the difference between V minus U, and the same has been written here. And now L into B for this rectangle is nothing but the reading over here gives the U value, initial velocity value, and therefore value of OD being T and value of AE being U. And from this parent equation, as we have already seen, we can derive this from this, and now we can replace this value with this value here because these two are equal. Therefore, and here we can simply write that T into T gives half AT square. Now we have arrived at equation number 2. One has been done here, 2 has been done here. Now we shall go into the third derivation using the same graph.